Increased electrical installation costs in hybrid wood frame and Type 1 metal frame construction can be attributed to several factors. Firstly, fire-stopping requirement. Type 1 metal frame construction necessitates a higher level of fire-stopping compared to wood frame construction. Electrical penetrations through fire-rated assemblies must be meticulously sealed with fire-rated caulk or gaskets. This additional sealing process demands more labor and materials, thereby increasing expenses. Secondly, grounding requirements. Metal frames exhibit greater conductivity than wood frames, thereby mandating additional grounding provisions. Grounding rods or electrodes must be strategically installed to ground the metal framework effectively. Moreover, electrical raceways and enclosures must be properly bonded to the metal frame to ensure electrical safety and compliance. Thirdly, wiring methods. In Type 1 metal frame construction, rigid steel conduit or mineral insulated metal sheet, or MIMS, cable is typically required for electrical wiring. These wiring methods are more expensive and labor-intensive to install compared to the cables commonly used in wood frame construction. The choice of wiring methods significantly impacts both material and labor costs. Fourthly, accessibility. Metal framing can present obstacles for running electrical lines, posing challenges during installation. Access panels or removable framing sections may become necessary to facilitate installation in certain areas. This can increase the overall time and materials required for the electrical work, consequently raising costs. Fifthly, coordination challenges. Coordinating electrical work between the wood frame and metal frame sections can be inherently challenging. Different materials and installation methods necessitate careful planning and execution. Effective communication and seamless coordination between electricians and other trades is crucial to avoid delays and errors, which can contribute to increased costs. Sixthly, inspection and testing. The increased complexity of electrical installations in hybrid structures warrants additional inspection and testing procedures. This can lead to higher inspection fees and potential delays in project completion. Thorough inspection and testing are essential to ensure compliance with electrical codes and safety standards. Seventhly, labor costs. Electricians specializing in metal frame construction may command higher wages due to their specialized skills and experience. The demand for skilled labor in metal frame construction contributes to increased labor costs. Additional considerations include the size and complexity of the remodeling portion, which will significantly impact installation costs. Larger and more complex remodeling projects will invariably require more extensive electrical work. Electrical codes and requirements vary by jurisdiction and may further increase costs. Compliance with local electrical codes is mandatory and can add to the overall expenses. The exact cost increase will vary depending on the specific project details. However, the factors listed above generally contribute to the higher electrical installation costs in hybrid wood frame and Type 1 metal frame construction. When planning a hybrid construction project, it's crucial to carefully consider these factors and budget accordingly for electrical installations. Let's dive into each of these points a bit more. Firestopping is a critical aspect of building safety, especially in Type 1 metal frame construction, which is typically associated with high-rise buildings and structures requiring enhanced fire resistance. The purpose of firestopping is to prevent the spread of fire and smoke through openings in fire-rated walls and floors. These openings are often created by penetrations for electrical wiring, plumbing, and other mechanical systems. In a hybrid construction scenario involving both wood and metal framing, the firestopping requirements can become more complex. This is because the fire resistance ratings and methods of achieving them can differ significantly between the two types of construction. For electrical penetrations, this means that each penetration through a fire-rated assembly must be carefully sealed with approved fire-rated materials. These materials can include fire-rated caulk, sealants, sleeves, or wraps. The selection of the appropriate fire-stopping material depends on the size and type of penetration, as well as the fire resistance rating of the assembly being penetrated. The installation of fire-stopping materials requires specialized training and expertise. Electricians working on these projects must be knowledgeable about the different types of fire-rated assemblies and the appropriate fire-stopping methods for each. Proper installation is crucial, as even small gaps or voids in the fire-stopping can compromise its effectiveness. Furthermore, fire-stopping is not a one-time task. It requires ongoing maintenance and inspection to ensure that the seals remain intact and effective over time. Any damage or deterioration of the fire-stopping materials must be promptly repaired to maintain the fire resistance of the building. Now let's talk more about grounding. Grounding is an essential safety measure in electrical systems designed to protect people and equipment from electrical shock and damage. In metal frame construction, grounding becomes particularly important due to the conductive nature of the metal. The metal frame can serve as a pathway for fault currents, which can create dangerous voltages if not properly grounded. The grounding system in a metal frame building typically consists of a network of grounding electrodes, grounding conductors, and bonding connections. Grounding electrodes, such as ground rods or plates, are buried in the earth to provide a direct connection to ground. Grounding conductors are used to connect the metal frame and other conductive components to the grounding electrodes. Bonding connections are used to ensure that all metal parts of the electrical system are electrically connected to create a low impedance path for fault currents. In a hybrid construction project, the grounding system must be carefully designed to address the different grounding requirements of the wood and metal sections. The metal frame must be grounded in accordance with applicable electrical codes and standards. This may involve installing additional grounding electrodes and bonding connections to ensure adequate grounding. Electrical raceways and enclosures, such as conduits and junction boxes, must also be properly bonded to the metal frame. This helps to minimize the risk of electrical shock by providing a low impedance path for fault currents to flow back to the source. Proper grounding is essential for the safety of occupants and the protection of electrical equipment in hybrid construction projects. Moving on to wiring methods, the choice of wiring methods in a building is governed by a variety of factors, including the type of construction, the occupancy of the building, and applicable electrical codes. In Type 1 metal frame construction, which is typically found in commercial and industrial buildings, more robust wiring methods are often required compared to wood frame construction. Rigid steel conduit, or RSC, is a common wiring method used in metal frame construction. RSC is a heavy-wall steel tubing that provides excellent physical protection for electrical conductors. It is typically used in exposed locations or where there is a risk of mechanical damage. Mineral insulated metal sheet, or MEMS cable, is another wiring method often used in metal frame construction. MEMS cable consists of copper conductors insulated with a mineral compound and enclosed in a seamless copper sheath. MEMS cable is highly resistant to fire, moisture, and corrosion, making it suitable for harsh environments. Both rigid steel conduit and MEMS cable are more expensive and labor-intensive to install than the non-metallic sheath cable, or Romex, commonly used in wood frame construction. This is because they require specialized tools and techniques for cutting, bending, and connecting the conduit or cable. In a hybrid construction project, the wiring methods must be carefully selected to meet the requirements of both the wood and metal sections. The transition between different wiring methods must be properly executed to ensure electrical safety and compliance. Now let's consider accessibility. Accessibility is a critical factor in the design and installation of electrical systems. Electrical components must be accessible for maintenance, repair, and inspection. In metal frame construction, accessibility can sometimes be challenging due to the presence of structural members and other building systems. Metal framing can create obstacles for running electrical lines and accessing electrical equipment. This can increase the time and effort required to install and maintain the electrical system. To address these challenges, access panels or removable framing sections may be necessary to provide access to concealed electrical components. Access panels should be strategically located to allow easy access to junction boxes, pull boxes, and other critical components. Removable framing sections can be used to create pathways for running electrical lines through tight spaces. Careful planning and coordination are essential to ensure that electrical components are accessible without compromising the structural integrity of the building. In a hybrid construction project, accessibility must be considered in both the wood and metal sections. The design should allow for easy access to all electrical components for maintenance and repair. Let's discuss coordination. Coordinating electrical work in a hybrid construction project can be complex due to the different materials, methods, and trades involved. Effective communication and collaboration are essential to ensure that the electrical work is completed on time and within budget. The electrical contractor must work closely with the general contractor, architect, and other trades to coordinate the installation of electrical systems. This includes coordinating the location of electrical equipment, the routing of electrical wiring, and the timing of electrical work in relation to other construction activities. In a hybrid construction project, it is particularly important to coordinate the transition between the wood and metal sections. The electrical contractor must be familiar with the different requirements and methods for each type of construction. Regular meetings and site visits can help to ensure that everyone is on the same page and that any potential problems are identified and resolved early on. Open communication and a collaborative approach are key to successful coordination in a hybrid construction project. Next, we'll touch on inspection and testing. Inspection and testing are critical steps in the electrical installation process. These steps help to ensure that the electrical system is installed correctly and safely. Electrical inspections are typically performed by local building officials or third-party inspection agencies. The inspector will review the electrical plans and inspect the electrical work to ensure that it complies with applicable electrical codes and standards. Testing is performed to verify that the electrical system is functioning properly and that it is safe to operate. Common electrical tests include continuity testing, insulation resistance testing, and ground impedance testing. In a hybrid construction project, the inspection and testing process may be more complex due to the different types of construction involved. The inspector must be familiar with the specific requirements for both wood and metal frame construction. Additional testing may be required to verify the integrity of the grounding system and the effectiveness of the firestopping. Thorough inspection and testing are essential to ensure the safety and reliability of the electrical system in a hybrid construction project. Labor costs can vary significantly depending on the location, the type of construction, and the skills and experience of the electricians. Electricians specializing in metal frame construction typically command higher wages due to their specialized skills and experience. Metal frame construction requires a different set of skills and knowledge compared to wood frame construction. Electricians working on metal frame projects must be proficient in the use of specialized tools and equipment, such as conduit benders and threading machines. They must also be familiar with the different wiring methods and grounding techniques used in metal frame construction. The demand for skilled electricians in metal frame construction can also drive up labor costs. In areas where there is a shortage of qualified electricians, contractors may have to pay higher wages to attract and retain skilled workers. In a hybrid construction project, labor costs may be higher due to the need for electricians with expertise in both wood and metal frame construction. The electrical contractor must carefully estimate labor costs to ensure that the project remains within budget. The size and complexity of the remodeling portion can significantly impact electrical installation costs. Larger and more complex remodeling projects will typically require more extensive electrical work. This may involve adding new circuits, upgrading existing wiring, and installing new electrical equipment. The cost of electrical work in a remodeling project can also be affected by the age and condition of the existing electrical system. Older electrical systems may need to be upgraded to meet current codes and standards. This can add to the overall cost of the project. The presence of asbestos or other hazardous materials can also increase the cost of electrical work in a remodeling project. Electrical contractors must take precautions to protect workers from exposure to hazardous materials. Careful planning and coordination are essential to minimize the impact of the remodeling portion on electrical installation costs. Electrical codes and requirements vary by jurisdiction and may further increase costs. Electrical codes are a set of regulations that govern the design, installation, and maintenance of electrical systems. These codes are intended to ensure the safety of people and property by minimizing the risk of electrical shock, fire, and other hazards. Electrical codes vary from state to state and even from city to city. It is important for electrical contractors to be familiar with the applicable electrical codes in the jurisdiction where they are working. Compliance with electrical codes can add to the cost of electrical installations. This is because the codes may require the use of specific materials, methods, or equipment. In some cases, the codes may also require additional inspections or testing. However, compliance with electrical codes is essential to ensure the safety and reliability of the electrical system. In addition to national and local electrical codes, there may also be industry standards that apply to electrical installations. These standards are developed by organizations such as the National Electrical Manufacturers Association, or NEMA, and the Institute of Electrical and Electronics Engineers, or IEE. Industry standards provide guidance on best practices for electrical design, installation, and maintenance. Adherence to industry standards can help to improve the quality and reliability of electrical systems. In summary, increased electrical installation costs in hybrid wood frame and Type 1 metal frame construction stem from a combination of factors. These include stricter fire-stopping requirements to prevent fire spread, the need for more extensive grounding systems due to the conductivity of metal frames, the use of more robust and expensive wiring methods like rigid steel conduit or mineral-insulated cable, challenges in accessibility due to metal framing, increased coordination demands between different construction types, and the potential for higher labor costs for electricians specializing in metal framework. The size and complexity of any remodeling work, as well as variations in local electrical codes, can further contribute to these increased costs. Understanding these factors is crucial for accurate budgeting and planning in hybrid construction projects.